All right, so this is notes 2.6, using linear models. For these notes, we need a calculator. So we need that TI-84 calculator. Hopefully you guys either downloaded one onto your computer. That's what I'm going to be using to do this lesson. So I had you download that 90-day free trial. If you were unable to download that, hopefully you got the one on your cell phone, like the Calculator X. I'm not sure if those are exactly the same, but hopefully similar enough where you guys can figure it out and figure out what I'm doing with this. And then, of course, if you have your own TI-84 calculator, take that out and have it with you while we go through these notes. You will have calculator tests and quizzes, so it's really important that we know how to use the TI-84 calculator and how to be proficient with it. So I'm going to go ahead and start today's notes. We're going to be doing a lot of that calculator stuff, so make sure you pause when you need to pause and you're keeping pace with the calculator. That's a lot to learn. All right, so we're talking about using linear models with data ultimately. So a graph that reveals two sets of data by plotting the data as ordered pairs is called a scatter plot. Okay, so scatter plot, remember those are the ones that just have a whole bunch of little dots everywhere. Okay, the correlation is the strength of the relationship between the data sets. A trend line is a line that approximates the relationship between the variables or the data sets of a scatter plot. We use trend lines to make predictions about the data. The trend line that gives the most accurate model of related data is called a line of best fit. Okay, this is the most accurate one. So here's the difference between this trend line and the line of best fit. Trend line is kind of like our own approximation of drawing a line that we think will fit the data well. So it's our own, we're just kind of eyeballing it, splitting the data in half. Line of best fit is calculated by the calculator, and it's the most accurate. It's the one that fits that set of data the best. Okay, so trend line, we do. Line of best fit, calculator does for us. All right. Okay, and then the correlation coefficient indicates the strength of the relation, or of the correlation, represented by the variable r. Let's go ahead and get some highlighters out. So represented by r. So r gives us our correlation coefficient. And then what we really need to know about r, because we will be evaluating r, what we need to know is that the closer r is to 1 or -1, the more closely the data resembles a line, and the more accurate your model is likely to be. So if you had an r value that is 1 or -1, that means that your line goes through every single point in that data. It's perfect. If we had a 0.999, that means it maybe misses one by a tiny bit, but it's still a really strong, good representation. If we're close to 0, that kind of means there's no correlation at all. We can't really draw a line. The data is everywhere. There's no trend. There's no really relationship or correlation between the data. All right, so we're going to look at visuals of that below. Okay, so these are visual correlations. So I like to use when I ask you to describe a relationship, I'm looking for 2 words, either strong or weak. In this example, they do high and low. I do strong and weak. And then positive or negative. Is it a positive or a negative correlation? Or maybe no correlation at all. Okay, so this one right here. So again, I don't say high, I like to say strong. So this one has a strong relationship. If you notice, very easily I could draw a line. It's all moving in a positive direction, that's why it's positive, and it looks like a line. So that is a strong positive correlation. This one, I can still tell the data is, it's still going in a positive direction. It's just not as tight to the line. So they're a little bit more spread out. And since they're more spread out, I would say this has a weak positive correlation. Still positive, but it's just not as tight to the line or not as close to the line. Okay, no correlation if you look at this one. It's everywhere. I could draw a line this way, this way, this way. There's no correlation here. Okay, and then the same things below. Only difference is instead of this moving in a positive direction, it's now moving in a negative direction. So I would call this one, if I drew a line in here, it would be tight to the line, so it's strong. And it's negative because it's moving in a negative direction. The line is negative, negative slope. This one, again, I can tell it's moving negative, but it's not as close. They're a little bit more spread apart between the lines. So this one I would say is a weak negative correlation. All right, moving on. Okay, so finding a trend line. So this is going to be us finding a trend line on our own, and then we're going to have the calculator find it, or find a line of best fit. So again, trend line means I'm doing it, I'm making the estimation, I'm just kind of like eyeballing it. So let's go ahead and look at this one. So step one, we are going to plot all the points. So I have 1, 2, 2, 3, 2.53, 3, 4, 3, 5, 4, 5.5, 4, 5.5, 4, 7, and 4, 6. Okay, this is going to be a little bit harder for me to do, just because I am on a computer and normally I would show you with a ruler, okay? So if you had a straight edge or something like that, what we would want to do is take that ruler or straight edge. We can see this is positive, and follow my cursor. The idea is we want this to go through 2 points that when I draw the line, I kind of have like the same amount of points on top of my line and the same amount of points on the bottom of my line. Okay, so hopefully that makes sense. So if we can use our imaginations, I'll go ahead and highlight. And since this is like we're making our own line, like let's make sure it goes through 2 points so I can easily find the slope. I can easily find the y-intercept. Like let's not make our lives hard. Okay, so if you guys look at this point right here and this point right here, if you guys can use your imaginations right now, if I drew a line through those points, I would have 3 dots above the line. So I would have this one, and this one above my line. And then I would have this guy, and this guy below my line. Okay, so that would be a pretty good trend line. Of course, it's not perfect. The calculator is the only one that can make it perfect. But I'm splitting that data in half as best as I can. So that would be a really good option for a line. With trend lines, everyone's going to have a different trend line. Unless, like, when I put it on a test, though, there's a very obvious trend line that I want everyone to see. Okay, so that's the idea behind it. So I'm going to pick these 2 points, and we're going to draw a line through those 2 points. So take a straight edge. Let's go ahead and draw our line. I'll make mine red. Okay, so if you guys notice, the next point, it would actually go through 0, 0. So if I drew this line, well, it shifted slightly, but whatever. Okay, that looks like a really good trend line. Again, I have 1, 2, 3 points on top, 1, 2, 3 points on bottom. It goes through 2 points on my data set. Good trend line. Okay, so we drew our trend line, and now we want to estimate what is the slope of this trend line. Obviously, I hope we're to a point that we know how to do rise over run and find a slope. It should be I went up 3 over 2, but just in case we don't, let's practice finding slope. So this is 0.23. This one is 0.46? Okay, remember slope, to find slope, it's change in y over change in x. So I'd get 6 minus 3 over 4 minus 2, which gives me positive 3/2. It should be positive because this is a positive line. And like I said, we went up 3 over 2, up 3 over 2. All right, following that trend line, but we're going to do it mathematically, we can see the y-intercept is 0, 0. Just by following our slope, now we go down 3 over 2. It's going to give me a y-intercept of 0, but let's practice our math and practice using all this stuff. So to find our y-intercept, we could go, okay, y equals 3/2 x plus b. We can just pick a point that this goes through. So let's pick point 2, 3. So y is 3. And x is 2. And now we can solve for b. So doing the math, we're going to get 3 equals, these 2's are going to cancel each other out, so I'm going to get 3 plus b, subtract a 3 from both sides, and we get 0 equals b, or b equals 0. So my intercept is 0, 0. Okay, now with all that information, we can write our equation of the trend line. We're just going to go ahead, keep it nice and easy. We'll do slope-intercept form. So slope-intercept form is y equals mx plus b. Our m is 3/2. X plus b. B is 0. Do not put plus 0. And that would be the equation of my trend line. All right, beautiful. All right, so now looking at this, creating a scatter plot. So the first thing I want us to notice is that we're comparing the fresh market price of Florida by the year and how much the box cost that year. So the first thing I want us to do is I want to change these years from 2006, 2007 to 1, 2, 3, 4, 5, 6, 7. Okay, the reason we want to do this is if we plug into our calculators 2006, 2007, those are our x values, and they're going to be way off of our screen, and it's going to be hard for us to find where the scatter plot is. So we want to just change it to 1, 2, 3, 4, 5, 6, 7. Okay, so what I'm going to go ahead and do, I'm going to go ahead and write the steps for our calculator, and then I'll show you on the calculator. Write the steps, show you, write the steps, show you. So please bear with me. All right. So the first thing that we're always going to do when doing lines of best fit or doing any regression line, these are called regressions lines. So we do quadratic regressions, cubic regressions, linear regressions, we do all the regressions. So the first thing we have to do is we have to turn on the diagnostics on our calculator. If we don't do it, you won't get the correlation coefficient, the R value, and then you're going to miss points on your quiz. Okay, so step 1, we're going to turn on diagnostics. Quite honestly, every time you get onto your calculator, I would always turn this on, and I'll show you how to turn it on. So to turn it on, so turn on diagnostics. Okay, we're going to hit second, and then we're going to hit 0, which is the catalog. That says catalog. And then we're going to scroll down to diagnostics on. Oops. So diagnostics on. And then you're going to hit enter. And enter again. So we're going to hit enter twice. Okay, so this is turning on our diagnostics. We're going to do this every single time. Okay, so I'm going to go ahead and pull out my calculator now. So here's my calculator, so we're going to do all the things I just said. So we're going to hit the second button. This blue button right here is the second button. Actually, before we do this, I want to show you how to clear your guys' calculator. I want us to clear our calculators just because it will reset everything back to like factory settings. So it'll clear out all the graphs, it'll clear out everything. I always recommend starting with a fresh calculator because if one thing is turned on, your calculator might not work for what we're doing. Okay, so let's start with that. To clear your calculator or to reset it, you're going to hit second, which is right here. You're going to hit the plus sign, which is memory, second memory. We're going to go to number 7 to reset. 7. We're going to go to number 1, all RAM. And then we're going to hit number 2, reset. And then it will say RAM cleared and your calculator is back to normal. Back to good. Can I move this? Oh, there we go. Okay, perfect. Alright, so turning on diagnostics, we go second. We go to 0 or catalog. You're going to scroll down. And these are in alphabetical order. So we're going to scroll until we get to the D's. And we're going to go to diagnostic on. Make sure it says on. We're going to go ahead, press enter. And press enter one more time. It has to say done. If you don't press enter that second time, it actually did not turn on yet. Okay, so step 1, diagnostics on. Okay, so now we're going to go ahead and we're going to input the data. Okay, so inputting data. So these are statistics. Okay, so whenever we have data, it's a stat, it's a statistic. So that's going to be the button we hit. We go to stat. And then we go to edit. And then we go to list 1 and list 2. Okay, in list 1, we're going to put the X values. In list 2, we're going to put the Y values. Alright, go ahead, pull up your calculator. Or whatever, however you're doing this. Okay, so right here is the stat button. So hopefully you guys see it. So we're going to hit stat. It's already on edit. So we're just going to press enter. So now it gives me my list 1, my list 2. So in the list 1, we're going to put 1, 2, 3, 4, 5, 6, 7. So we're going to go 1, press enter, it'll automatically move down. 2, 3, 4, 5, 6, 7. Okay, so make sure that in this list 1 we have 1, 2, 3, 4, 5, 6, 7. Guess I can make this a little bigger for you guys since you guys can't see the chart anyways. Okay, so that's what the screen would look like. Okay, then we go over to list 2. Oh, list 2. So arrowed over to list 2. In list 2, we're going to put those Y values. So the first one's 840, so we're going to put 8.4. Enter. 15.99. Enter. 10.75. Enter. 880. 8.8. You do not have to put zeros on the end. 1275. 1291. And 1312. Okay, I would always double check this. If you have one number off, you're going to get everything wrong because you have one number off. Okay, so double check that. Okay, so then what we want to do to get off of this page, we just go to second mode or quit. So then we get back to the home page. So then we want to go back to the home page. Okay, so we'll put that right here. To go back home, we hit second mode, which is really quit. All right, next step. I'm going to go ahead and slide me up. Okay, so now the next step is going to be to graph my scatter plot. Sorry, my handwriting is not the prettiest with this little electronic pen thing. All right, so to graph our scatter plot, we're going to go second. We're going to hit the y equals, which is really stat plot. Then we're going to go to number 1, and then we're going to turn it on. Okay. We're then going to choose the graph, choose graph, adjust L1 and L2 if we need to, and I'll tell you what I mean by that. Then we're going to hit the graph button. Let me help you guys. The ones in boxes, those are buttons. Yeah, that might make it easier for us. Let's go ahead and do that. So let's fix all this. So if it's in a box, it's actually a button. The other things are just like within that function. This is a button. This is a button. And this is a button. Okay, so hopefully you guys understand that. So then we're going to hit the graph button. And then we're going to hit the zoom button. And then we're going to choose number 9, which is zoom stat. Alright, so go ahead, pause if you haven't written all that down and made those edits. Pause it here, otherwise I'm going to the calculator. So, going to the calculator. Okay, so the first thing it tells me to do is I hit second y equals. So here's the second, and y equals is right here. Second y equals. Okay, so if you notice, all of my stat plots are off, which they should be. So we're going to go to number 1, press enter, and we want to turn it on, so press enter. Okay, so now it should be blinking on. This right here, we get to choose what kind of graph we want. Do we want a scatter plot? Do we want a, what's that called, a line graph? A bar graph? A box and whisker graph? We pick which graph we want. We just want to scatter. My X list is in L1, my Y list is in L2. Sometimes people like mess with the calculators. They accidentally delete L1 and L2. So maybe it's in L2 and L3. Right here you would have to change this to L2 and L3. If you guys notice above 2, 3, 4, it has L1, L2. So you would hit the second button and L2 or whatever to switch those if you needed to. Your guys' should be good. Usually when we factory like hard set them like I did in the beginning, it should have fixed it. If it didn't and you need help fixing it, you could always contact me and I can help you fix that. Okay, if you want to change the color, you could totally change the color if you wanted to. Maybe you want a red one, black, magenta, it doesn't matter. Okay, and then this is all good, this is all set. So now we hit this button right here called graph. Alright, so if you guys notice, my graph, not all of my information is here, right? I had more points than that. I should have 7 points I should be able to see. So that's when we do the zoom. So zoom is zooming to the proper location. So we hit this button, zoom. Okay, we go down to zoom number 9. That one says zoom stat. Well, we did a stat, so it makes sense to zoom the stat. So we're going to zoom number 9. And then it will perfectly set up your window to zoom to that stat. So these are all of our points in our scatter plot. Okay? Okay, so our last thing we need to do is we're going to go ahead and find the line of best fit and then the correlation coefficient. So this is what we're going to continue to do, finding these lines of best fit. These regressions are called regressions. we're going to continue to do that throughout the class. So we will do this several times. So hopefully you are understanding it, understand the process. Okay, so let's go back here. All right, so now we're going to go ahead and find that line of best fit. So to calculate line of best fit. Okay, so we're going to go back to our stat button. We're going to move over to calc because we want to calculate my line of best fit. We're going to go to number 4 that says lin reg. So that means linear regression. I want to find the linear regression. Okay, this is the part that most people forget. We have to store the regression equation. If we don't store the regression equation, it's not going to draw it in my scatter plot. Okay, so to store it, we hit alpha F4, and then we choose Y1. And then we're going to hit calculate. All right. So let's go back to our calculator. So here's my calculator. Okay, we want to go back home. So to go back home, remember you need to go second quit or second mode. Take me back to the home screen. We're going to go to stat. Okay, so before we did stat edit, that's where we put in the list. Now we're going to go move over and we're going to go to calculate. So over one and now we're in calculate. Okay, we want to calculate a linear regression. So we want to do number 4. We like the form ax plus b, right? We don't write our equations of our lines a plus bx. We don't like that. We write it as mx plus b, ax plus b, okay? So we're going to choose number 4. We want to use list 1, we want to use list 2, unless, again, if yours was messed up and maybe yours is 2 and 3, then you need to switch these. Scroll down, and we need to store the regression equation. So this is where most of my kids forget. Store the regression equation. How we store it is we're going to hit alpha F4 or alpha trace. Okay, it's the alpha and then the trace button. So alpha is this green button. And if you guys notice right up here on this trace button is a little F4. So it's the trace button. And then it pulls up Y1, Y2, Y3, Y4. So we're going to just choose Y1. Okay, so now it's going to store it in my Y1. That's what we want it to do. We're going to scroll down and we're going to hit calculate. Enter. Okay, this gives you your regression equation. You have to plug it in to the into the actual formula. So this is the A value, so that's going to go right here. So it'll read 0.357x plus 10.388. I round 3 decimal places in my class unless it says otherwise, so I like to standardly we do 3 decimal places. So let's start practicing rounding 3 decimal places for these, okay? So then I get an R squared value and an R value. Okay, so this R value right here gives me my correlation coefficient. So 0.287, that is very weak. The reason it's weak, remember what I was saying, is the stronger it is, the closer it is to 1 or -1. Well, this is not close to 1 at all. So this is a very weak but positive, because this is a positive number, a very weak but positive correlation coefficient. Okay, so let's go ahead and write our line of best fit. I'll do it in a different color. So my line of best fit is y equals, it was at 0.357x plus 10. It would have rounded to 0.39. My R value is 0.288. And this R value tells me that it is a weak positive correlation. Barely any room. Okay, and that's my line of best fit. let's go back to our calculator and we can see it drawn into our data. So back to my calculator. So when we did that whole store to y1, if you guys go hit y1, that equation, without it being rounded, the actual equation is stored in here. So when I hit graph, it will draw my line of best fit in my data. And as you guys can tell, this is super weak. Like, look how far away this guy is from the line. There's some way down here. It's not all close and bunched together to this line. That is why it is a weak correlation. All right, moving on. Next page. All right, so here we're going to be doing fast food hamburgers versus chicken. Okay, that's very random. So there is a relationship between fat grams and the total calories in fast food sandwiches. Use the data in the table to investigate. I don't know why it has fast food hamburger versus chicken. I don't know what that is. But what we're doing is we're comparing the fat grams to the calories in fast food, different fast food items. Okay, so all of your guys' directions are on the last page, so we're going to go back through those same directions. I am not going to write all those again. We're just going to go through them because we already have it written down. So let's go to our calculator and let's get started. So back to my calculator. So the first thing I want to do is I want to clear out. So I have all this information in my calculator. Like, start with a fresh page so you don't ever get messed up. So let's start over. Again, to start over, you hit second plus sign, which is memory, and then it's 7, 1, 2. 7, 1, 2. All cleared out, so now I don't have to worry about like erasing the stat plot and doing all that stuff. It's all cleared out, we're good to go. Okay, so first thing you always do, turn on your diagnostics. Second, 0 or second catalog. You scroll down until you find the D's. Okay, and we want to go to diagnostic on. Press enter. Make sure you press enter one more time until it says done. Now your diagnostics is on. If you don't do this, you won't get an R value and you can't tell me the correlation between the data. Okay, next we go to stat. We go to edit. We type in all that data into list 1 and list 2. So, I'm going to just pause the video so it's just not taking up too much time. Go ahead and type all those data into the thing, and then I'll unpause this video once I start again. Alright, so I typed all of my data into list 1 and list 2. Again, double check that you have it all correct. You make one mistake and everything's going to be wrong. Okay, so now we're going to go second quit, so that just takes me back to my home screen. And now we want to graph this data, so we're going to go ahead and graph it. To graph it, we have to turn on the stat plot. So you're going to hit second y equals or second stat plot. You're going to choose number 1, and we're going to turn it on. Okay, this should all be set up good, so it should be good to go, and we're going to hit graph. Okay, notice this graph, we can't see any of it, so we have to zoom to the stat. So we hit zoom, and we go to zoom stat, number 9. Alright, so there's my scatter plot. This looks like a very strong correlation, just looking at it, right? This is strong and it's positive. It's all moving up and it's pretty tight and close together moving. So I'm assuming that my R value is going to be a pretty close to 1 R value. So we will check and see if that is true. Alright, so let's go back to here. Scroll down. Again, we don't do this. This is way too much. We just do zoom number 9, zoom stat. Okay, so now we're going to go ahead and find our line of best fit. So hopefully you guys remember how to find our line of best fit. So to find our line of best fit, we're going to go back to our calculator, obviously. Go back home, second quit. So home page. We go back to the stat. And now we're going to move over because we want to calculate the linear regression, so number 4. Okay, list 1, list 2, good, good, good. People always forget to store your regression. You must store this. So we hit alpha F4, alpha trace. So I go alpha trace or alpha F4, choose Y1. Go down, press calculate. Okay, look at that R value, 0.972. That is extremely close to 1, which tells me this is a very strong correlation. Very strong, super strong. Okay, and then it gives us our line. So again, remember we need to go ahead, write down this line. So it's going to be 11.258x plus 234 plus, or not plus, 234.745. All right, so we're going to go write down that information now. So writing down that information, my line of best fit was y equals 11.258x plus 234.745. Okay, let's go ahead, write down our R value right here. So our R value was 0.972. So this is a strong positive correlation. All right, now we're going to take this a step further. So now it's going to ask, a chicken sandwich has 12 grams of fat. What are the total calories in the sandwich? So we're going to use this line of best fit to figure out how many calories would there be for 12 grams of fat. Some of you guys are going to go right here and plug in 12. You cannot do that because it's not accurate, because we rounded this and we rounded that. It'd be close, but it's not the actual answer I'm looking for. So I'm going to show you guys how to calculate this on our calculator. So we're going to go ahead and write down the steps. So we're going to hit graph. That's a button. We're going to go to second. Again, a button. We're going to go to trace, which really I'm going to calculate. On top of trace is calculate when I hit second. We're going to go to, I think it's number 1, value. Okay? In there, we're going to put x equals 12, and then we'll press enter. And then this is going to give you y. So it gives y value. That's what we're looking for. What is the y value? How many calories? All right, going to our calculator. Let's do it. So let's go back home. Second quit, second mode. We're going to hit graph. Okay, very strong correlation. These are all close and tight to that line. This is a great line of best fit. Okay, so now we're going to hit second trace or second calculate. Second trace. Number 1 is value. You're going to hit enter. Right down here it says x equals, we want to know when x is 12. Press enter. And it tells me when there's 12 grams of fat that there's going to be 369.846 calories. And that's the answer to the question that it asked me. So let's go ahead and write that down. So y equals 369.846 calories. So this is my answer to the question. Okay, so now we're going to just talk about the idea behind this. So it says, in the context of the data, what does the y-intercept represent? So what would my y-intercept represent? Okay, so my y-intercept would represent, so let's see, what is my y-intercept? So my y-intercept is 234.745. So that represents if x, and x is your fat, if there's 0 fat, there's still going to be 234.745 calories in the sandwich. So that's what that means. So in a sandwich, how do you spell sandwich that has 0 grams of fat, there would be about 235 calories. Beautiful. All right, we have one more page we're going to go through. The last 2 pages are just directions on the calculator. I personally like my directions better. I think they're better, but those are always there for reference. One of them's a TI-84 directions, and the other one's TI-Nspire. We use the 84. All right, so let's go to number 4. Okay, what I would really like you guys to do right now is to pause this video, and I want you guys to try this one start to finish. And when I say start to finish, the first thing you should do is reset your calculator. So again, to reset my calculator is second memory or second plus sign 712. So start there and attempt this. Go back to the page with the directions and try to attempt this all by yourself, and then check and see if you got it right. All right, so let's go ahead and go through this now. So I'm going to go back to my calculator. Reset it. Second memory 712. Reset. I go to stat. I go to edit. And I type in my list 1 and list 2. I'm going to pause my video. I'm going to do that and come back. Alright, so I've put all my data into my list 1 and my list 2. Okay, next thing we're going to go ahead and do, let's go back home. We're going to turn on our stat plot. So that's second y equals, or second stat plot. Go to the first one. Turn it on. Everything else should be set up. We should be good. Let's hit graph. Okay, again, I don't see anything on my graph. Okay, so we need to go ahead and zoom number 9, zoom our stat. Alright, so now I can see all of my data on my graph. Good to go. Next, we're going to go ahead and find that line of best fit. So let's go back home. To find the line of best fit, we go back to stat. We go over to calculate. And then we're going to calculate the linear regression, so number 4. So again, list 1, list 2, good, good. Scroll down. Store your regression equation. You must store it. Alpha F4, alpha trace, Y1. Go down, press calculate, and enter. Ooh, great point. I made a mistake. Okay, so how I know I made a mistake is because I don't have an R value. If you don't have an R value, that means you did not turn on your diagnostics. So right now, you're fine. Everything can stay. We just need to go turn on that diagnostics and then recalculate that linear regression. So that's what I'm going to do now. So I'm going to go second, catalog, scroll down to D's, diagnostic on, and press enter. Okay, so now I have to redo that linear regression one. So I go to stat, I go over to calculate, I go to number 4, linear regression. I store my regression, alpha, F4, Y1, down, calculate. Okay, now I have my regression. Beautiful. So this would be considered a strong, and it's negative because it's a negative number. So this is a strong negative correlation. And then we're going to go ahead and write down my equation, and we're going to write down this R value. Okay, so how would you describe this correlation? So my correlation was R equals negative 0.904. So again, I would call this strong. It's close to negative 1. And I would call this negative. So this has a strong negative correlation. Okay, what is my line of best fit? So that was y equals negative 7.907 x plus 98.051. Okay. One more thing we should talk about here. So what we were comparing was the number of hours spent online and then test scores. And this wants to say correlation does not necessarily mean causation. So what does that mean? So correlation does not mean causation. So just because there's a strong correlation between this data set, it doesn't mean that, well, just because this kid spent 5 hours online, he scored the lowest because he spent all his time online. So we can't say that these have a direct influence on each other. Okay, so correlation does not mean causation. So some reasons we could say that is maybe that kid who spent 5 hours online, maybe he was studying the entire time. And maybe the kid who spent 0 hours online, maybe he's grounded from his computer, but always does well on his tests anyways and just studied. Whatever the case is, we don't know the circumstances. So we can't say, well, if you spend 5 hours on the computer, you're going to fail your test. We can't say that. We can't draw that conclusion. So we would have to say no conclusion can be drawn since the online computer time could be related to test prep sites. Whatever the case is, there's 5 million reasons that we could not draw a conclusion about this. Okay, I know this has been a long one, and it's tedious. Calculator stuff is tedious, 100%, but we only have one more, and we're going to make it through it fast. Okay, so for this one, we're comparing the year and then the cost of 2% milk. Just like the one that we did with the year before, I do not want you guys to put 1998, 2000, 2002, 2004. We're going to just change the years, okay? So I'm going to actually call 98, we're going to call that year 0. Okay? Please pay attention. From 98 to 2000, that's a 2-year difference. So that would be year 2. And then this would be year 4. And this would be year 6. And this would be year 8. And this would be year 10. Careful, this one jumps 4, so this would be year 14. Okay? This question down here, so let's talk about this right here. This question wants to know what it would be in 2015. So for 2015, what year would that be? So from here to here is 3-year jump, so that would be year 17. All right, we're going to go through everything again. Hopefully you're starting to get the hang of it. You're getting the flow of it, what we do every single time. So I'm going to go ahead and start. Step 1, let's go ahead and clear these calculators. Second, plus sign, 712. Everything's cleared. Okay, we want to plug in numbers. We want to do statistics, so we're going to go to the stat button. We're going to edit it. And we're going to put the X's in 1 and the Y's in 2. I'm going to pause my video here, type them in, come back. Alright, so I've plugged in all my data. If you guys notice, please don't put a 17. We don't know what the price was in 2017. We're going to find that out. So it needs to just end with what it gave us. Okay? Okay, from here, we're going to go ahead, turn on our stat plot. So we're going to go second, Y equals. Choose number 1, we're going to turn it on. And enter. Okay, and then we're going to hit graph. Okay, again, we want to zoom just our stat, so we're going to go zoom number 9, zoom stat, and there it is. I just thought about it. I didn't turn on my diagnostics, even though I always stress to turn it on. So let's go turn on our diagnostics now. So let's go second, quit. Diagnostics on. We hit second, 0. We scroll until we get to the D's. Go to diagnostic on, press enter. You must press enter again until it says done. Okay, now it's on. Okay, now we're going to go find our line of best fit. We go back to stat. We scroll over to calculate. We want to do a linear regression, number 4, so we hit number 4. Okay, should be in list 1, should be in list 2. Scroll down, we need to store the regression. Alpha F4 or alpha trace. Choose Y1. Press down, press calculate. All right, there we go. Look at our R value. This has a strong positive correlation. So yes, as the years have gone on, the price of milk has gone up. Okay, so we're going to go ahead and write down these numbers for our line of best fit. So it wants to know what was our correlation. So our correlation was 0.951 rounded. So this is a strong positive correlation. Okay, is there a clear correlation? Yes, it's strong. There's a clear correlation between the data. Find the equation of the line of best fit. So that was y equals 0.094x plus 2.542. Again, we're rounding 3 decimal places. All right, so now the last question, the one that we haven't practiced as much. Based on your linear model, how much would you expect to pay for a gallon of milk in 2015? So this is the same one that was like our example number 2 about finding, I forget what it was. What were we finding? Oh, finding the calories based on the fat. Same idea. So we're going to do that process again. So if you need help, go back to example number 2. I wrote the directions there. So back on our calculators. This should be stored because I stored this. We're going to go back to our graph. So there's my graph with my line of best fit. Using my line of best fit, we're going to find how much milk would be in, or how much it was in 2015. Okay, or the estimate given by our line of best fit. So to do that, we hit second trace, or second calculate. So whenever we want to calculate, like all of these little ones, all have to do with, or all these buttons up here have to do with the graph. So I want to calculate on my graph, so that's why I'm using this calculate up here. So this is all to do with the graph. Okay, so we're going to calculate a value. Okay, we want to know in 2015, which was year 17. Press enter. We have a problem. So, and this is good to talk about. So it says there's an error. We can't do it. So let's go back to our graph. The reason we can't do it is because this graph doesn't go to 17. It gets cut off. So what I have to do is I have to adjust my window to make sure it includes 17, and then it will work. So how do we do that? We go to window. So like it tells me my x minimum is negative 1.4. Well, right now my x max is only at 15.4. I need it to at least go to 17. So maybe let's change this to 18. And then hit graph again. And now we're going to try that again and see if it works. So we're going to go second, calculate. Okay, we want to calculate a value in year 17. Press enter. And look, now it works because it's in my window of my graph. So in 2017, this line predicted the cost of milk would be $4.14. I honestly have no idea how true that is. I don't drink milk, so I don't even know how much milk costs today. So I'm assuming it's not that expensive, but who knows? Okay, so it would be $4.14. This one I'm going to round 2 spots. Why would I round this one 2 spots? Because I'm talking about money. Money doesn't go 3 spots, money goes 2 spots, so we round it 2, so it makes sense. Alright, so let's go ahead and write that down. So, we would expect when x is 17, y was that 4.143. Again, we're not going to put that because we're talking about money. So it would cost $4.14. All right, thanks for bearing with me with all this fun calculator stuff. So again, the next page has the TI-84 information. This is the one that you would use, so you guys can easily reference this as well. Notice they don't turn on diagnostics and stuff like that. Personally, I like my directions better. But this is another option just in case you guys need some help. Other than that, if you have questions about the calculator or anything like that, you know where to find me, and have a great day.